Let's study the relationship between the electrical work and the heat generated in a small electric motor under different operating conditions. In order to measure the heat capacity, we will be using two cell batteries connected in parallel, two digital multimeters, the ammeter has a full-scale range of 10 amperes, and the voltmeter has a full-scale range of 20 volts. We will also need a stopwatch to time the circuit work. Here's the electric motor. Now we're putting it into a box insulated with styrofoam. The electric motor is fastened to a pulley with a rubber belt. We will leave it running but not moving. We will be using a thermometer with a full-scale range of 50 degrees Celsius. The notch can mark 0.25 degrees Celsius, that is a quarter of the scale.
We will attach a closed peg to the motor shaft to hold it in place. The only effect will be the generation of the heat. We are going to use parallel connected batteries to obtain a more constant current. This one is the ammeter and this one is the voltmeter. While letting the fixed motor run for some time, you will record the potential difference with a voltmeter and the current with an ammeter. In this way, you can calculate the electrical work produced by the batteries. This is a stopwatch for timing the experiment. Let's record the initial temperature of the electric motor. 25.75 degrees. We're going to turn the circuit on and let the charge flow around for about a minute. The values of electrical charge and voltage are recorded. The temperature should have reached the top now, 27.0 degrees.
This experiment aims at checking whether or not the electrical work produced by the batteries is equal to the heat generated in the electric motor when it is allowed to run freely. In this experiment, as well as in the other cases, a set of 4 batteries with 4 flashlight cells each will be used. You will also need an ammeter, a voltmeter, a stopwatch and a thermometer. Let's record the temperature before starting the electric motor. (25.75 degrees). Now let's turn the circuit on for a minute.
We have fixed the electric motor shaft to a pulley with a rubber belt. We will allow the motor to run in neutral.
Off. 60 seconds sharp. 28.75 degrees.
The next condition where we want to measure the heat produced in a motor is when it is lifting a container filled with water. You will need the same equipment as before: 2 multimeters, a stopwatch, a set of 4 batteries, and a thermometer. Let's record the mass of the container. Its mass amounts to 3.5 kilos. With this nylon thread, we have connected the container to the motor. The initial temperature is 26 degrees Celsius. 3, 2, 1, go! Can you disconnect the container, please? The final temperature is 28.5 degrees.
The last phase involves repeating the experiment with the container filled with water under different operating conditions. The container will be lifted as before, but once the circuit is turned off, it will be dropped to the ground slowly without disconnecting the motor mechanically. The same equipment as before will be used. You should remember that we are trying to understand where the missing heat has gone. The initial temperature is 25.5 degrees. Now the motor is lifting the container, but soon it will drop down very slowly without disconnecting from the pulley. "55 seconds. "29.5 degrees.